Okay, so I'm not going to go through these questions completely. I'm just going to kind of get them started. You guys have had a lot of experience thus far, so let's look at number 5. Our galaxy, the Milky Way, contains approximately 4 times 10 to the 11 stars. So it has this many stars with an average mass of this each, right? So it's saying each one of these stars has this much mass. How far away is the Milky Way from our nearest neighbor, the Andromeda Galaxy? If Andromeda Galaxy contains roughly the same number of stars. Okay, roughly the same. We're going to go with that. And tracks the Milky Way with a gravitational force of this. Okay, so let's go back to old school. Since this is a little bit different, let's write down what we know. We know the force of gravitation is 2.4 times 10 to the 30 newtons. And we know that the mass of the Milky Way equals, well, it says it has this many stars, and each star is this much each, so we're going to have to do this times this, right? So we know it is 4.0 times 10 to the 11 times 2.0 times 10 to the 30. That's going to give us the mass of the Milky Way, and that's also going to give us the mass of Andromeda. Same thing, because remember, they said they have the same number of stars. 4.0 times 10 to the 11 times 2.0 times 10 to the 30. Okay, so this is mass 1, this is mass 2. So let's look at what we have. Remember our formula. Ooh, I'm falling into actually answering it. So just remember our formula. Force equals the gravitational constant times the mass 1 times the mass 2 divided by the distance squared. So right now it looks like you have the force, you have the mass 1, and you have the mass 2. So I almost did it, but I'm going to stop myself. We'll figure that one out later. Actually, you'll figure it out. Give it your best shot and ask me if you have any questions. Alright, so let's talk about number 6. So number 6 is a little bit different. It's a little bit of a throwback from to like Newton's laws, Newton's force laws and stuff like that. Remember, you had to do like a force diagram. So let's look at it. Tides are created by gravitational attraction of the sun and the moon. Awesome. On the earth. Calculate the net force. Oh, throwback word. Net force pulling on the earth during A, a new moon, B, a full moon, and C, a first quarter moon. So let's do this first off. We're going to go ahead and omit C. We're not going to worry about C because that's just going to muck up our problem. I don't want to mess with that. So we're doing net force. Net means like the winning force, right? Or in other words, like if both forces are on this side, that means you're probably going to add them together. That's the net force to the left. If you have a force here going to the left, this force going to the right, whatever one's winning, the leftover is going to be the net force. So if this force, let's say, let's do my little mini diagram over here. This is the sun. If the sun's pulling at a force of 10 newtons to the left, and here's the earth. That's the earth, right? And the moon over here is pulling at a force of 2 newtons to the right. Well, the net force is 8 newtons to the left, right? And this is our net. Okay? So just keep that in mind. So what you're going to have to do for this one is you're going to calculate the force of the sun, its gravity on the earth, pulling obviously to the left. The force of the moon's gravity on the earth. It doesn't matter which side it's on, it's going to have the same force, just one way it's going to be left, one way it's going to be right. And then, again, we're not doing answer C, so we're going to omit that. And we're just going to do A and B. So let's make A, well, actually they already give it to us, right? So A is going to be what? New moon. So they're both on the same side. And B is going to be full moon. So one's on one side, one's on the other. Hopefully you guys get this. Give it a shot. It's not as nearly as hard as it looks. It's actually relatively easy. You're going to do great.